Hello, everybody. Well, first of all, thank you for the opportunity to be able to present. It's the first time that Epic Labs presents at an event like this, so for us it's a very special occasion. What could possibly be EtherGit, right? Out of the name, probably give some clues. But yeah, let me introduce myself a little bit and Epic Labs, and then we can continue. So today I'm gonna talk a little bit about Epic Labs very quickly. Then we're gonna talk about EtherGit, how it works, and then we're gonna set out and do a demo because that's the fun thing, right? So very quickly about Epic Labs and myself. We are a software innovation center based out in Madrid, in Spain. We're helping small and large companies in innovation processes. We are experts in video streaming, video encoding, and anything that has to do with machine learning applied to video. However, today we're not going to talk about video streaming. We set out one year ago to provide some blockchain consulting services as a way of kind of coming out of the closet, because we were really wanting to do that. So we picked one project we could work on, and the idea was to start testing the waters and do an actual application and see what problems we would find along the way. Okay. 3 of our founders come from Akamai. As you may know, Akamai is a content delivery network. So one of the interests out of the Web3 stacks is the whole Swarm project, because it has all those features about storage, about distributing all the information around the internet. Okay, so that was very, very interesting for us to start tackling the waters in there. So we are, okay. Sorry. Okay. Yeah, we're a team of 25, and the part of the team that is working on blockchain services is around 3. So for us, it's a big percentage. So what is EtherGit? So the idea here, and I could summarize this as getting GitHub out of the way. But the idea is to combine Swarm storage with Ethereum smart contracts to scalably and safely host source code with the high availability of a distributed network, okay, and enforce how the code is governed, and do that with full transparency about the rules that the community will follow to update the code, okay, and as well to decentralize that workflow that we are involved every day, right? We submit an issue, a bug report, or a pull request, okay? So all that. Right now we're doing it on GitHub, so the idea would be to not have to use a centralized service for that. And at the end, when everything is set up, then we can start incentivizing people to resolve issues, with some sort of internal economy in there to make sure that people are solving the right issues, out of the maybe hundreds of things that we need to do in an open source project. But before we jump into EtherGit, let's take a little bit a look at prior art, similar projects. And when we set out to start with EtherGit, we found at least these 3. Probably there are more attempts at achieving this. We have Git torrent, which is pretty much just storing all the Git repository in a torrent. Git on Scuttlebutt, which is this messaging append-only database where you can store information. And then the one that got me really excited about was Mango, but the only problem that I see is that at least I couldn't find any updates on Mango in the last 2 years, so for me it was a little bit disappointing. So we started about 3 months ago to start building EtherGit. This is very much work in progress for us. Today is actually very early or too early to show what we're doing, but our idea was to get feedback, to see what everybody thinks, and see if this is worth continuing, and what is, what are the ideas or what are the things that people need to use this. Okay. So about components and features of EtherGit. EtherGit comes with a Git plugin. So this is something that you install on your machine. Fortunately, Git is a system that is extensible. Okay. So it comes with the possibility of adding new protocols to the stack. The one that we use the most is SSH. Every day we are using SSH to push code, but Git is extensible, so you can create your own plugin so that you can support any backend. Okay. We also provide a JavaScript library that can be used to build web applications, and that's one of the applications that we're going to show you today. It also comes with a Golang library in case a more backend type of application needs to connect to EtherGit. And then we're also going to be showing an HTML5 DApp. That is, its idea is to allow you to browse the code and interact with others with your browser. I mean, like in an everyday situation. And then in terms of architecture, the smart contracts that back up any repository are modular. So it means that you can bring into your contract the features that you need for that particular situation. Okay. Okay. So let's dig a little bit into it. Okay, so as many of you know, a Git repo is sort of like a blockchain, right? Because at the end, all those commits are referencing the previous one, okay, with a hash. So that is like a blockchain. The thing is that the hash algorithm that is used for referencing those objects in Git is a SHA-1, which is, as of today, unsuitable for securing code. But it's useful for just making sure that the code was not, damaged or whatever. Okay. The thing is that obviously we're not going to change the whole Git and all the repositories that are out there. So there's some things that we need to do in order to be able to use SHA-1 in this system. Also, when we use Git, all the code governing logic is not part of this repository itself. All the governance of our code is based on whatever tool we're using, for example, GitHub or Bitbucket, where they allow you to create accounts and then you set branch permissions and things like that. All those things are not part of the repository itself. And then also, and most importantly, all the issue and pull requests and all that history is kept in the tool that we're using, for example, Bitbucket or GitHub. So I know that if our Bitbucket or GitHub disappear, everybody has a copy of the entire Git repository in their machines, but one of the things that we would lose is the entire pull request history and issues, and that's one of the things that makes you hostage in the system you are. Okay, so if you base your project in GitHub, then if you want to move the Git repository, that's fine, but all the the pull request history and everything, which has a lot of value, you would lose, and you would keep it in. You would be hostage there. Okay. So how does EtherGit work? So we start off by I'm going to talk about an example in which it's just a repository with one file and we do one commit. Okay. If we do something like that, when we do a commit of that single file, Git is going to start creating some objects, okay, that is going to be storing that .git mysterious folder that we have in our project, okay. So for a code file, it's going to create a blob object, okay, and it's going to calculate a SHA-1 hash of that blob object. And since that blob object is going to be in a directory, for example, the root directory of our repository, it's going to create a tree object. Probably it's not very readable, but on the right side we have a blob object. In the middle we have a tree object, okay? And what it's going to do is going to have that SHA-1 hash point to that blob object, okay? And then when we commit, it's going to create a commit object with our name, with a commit message, and it's also going to contain a link, a SHA-1 hash of the tree object, which in turn contains a hash of the blob object, and also the commit object has a hash of the parent commit, and that way you get the full. At this level, you get a snapshot of the code at that point, And then if you go down, then you get all the history and how the code changed, okay? And last, what you do is you update the branch pointer so that you know that branch 1 or master or development branch point to that particular commit. Up until this point, there's nothing new here. This is how Git works, okay? The idea is how we put this structure to work in a decentralized way, okay? This is on our computer. How do we push it to Swarm? So to do this, we have to do a little bit of work. So in order to upload those blob objects and tree objects and commit objects to Swarm, we need to start doing some magic in here, okay? So the first thing that we do is we wrap each of the objects with a header that is going to give us some meta information about that particular object. We call it the EtherGit header, which contains just a version of the protocol, a compression flag to see if we are going to be compressing the object or not. In the case of tree object, we're going to be also including a Swarm hash of the previously uploaded blob object. So that way we can keep a double reference, okay? We keep the SHA-1 reference, which is the one that Git needs, okay? But we also create a Swarm hash reference so we can also pull that object out of Swarm. And for the commit object, we do something similar. We just wrap it. We put the Swarm hash of the previous object that we have uploaded, and also the parent of the parent hash of the parent object that we also have uploaded. Okay. So at the end, we are replicating all this pointer structure in a way that Swarm can understand. And then the key difference is that when we have to put the branch reference, we store that branch reference into a smart contract. So that way, the smart contract is going to be managing what particular branch or what particular commit is the real version of the code that we want to publish or that we want to show everybody. Okay. So branch 1 could be master. So every time that we commit to master, then we're really saying to the world, hey, you know, this is the best version of our code so far, and we're publishing it here. So at the end, that small block in there is small, but in that smart contract, you are really defining what are the rules of engagement of your open source community around your code. So if anybody can push, who has permission to what branch, okay, whether or not you need to have a certain amount of tokens to do a pull request, you know, all those rules you can configure and define in a smart contract. That's up to you to define, okay? EtherGit defines sort of like an interface to have that communication with the contract, okay? But it's up to you to define the rules of engagement of your community, okay? So at the end of the day, what you get is a team of developers use the remote helper, the Git plugin, to talk to Swarm and the Ethereum repository. And then you also have developers using the web distributed application to visualize the code in a more friendly way, and also work in the review process. You know, do I merge this pull request? Do I answer to this issue? All those things you do on the web interface. Okay. Okay. So with all this explanation, then we can do a demo and see how that looks. So what we're going to do in the demo is we're going to deploy a new repository, which is actually deploying a smart contract. Okay. We're going to take a look at that smart contract. I didn't put anything that was very complex. Then we're going to push some changes to that repository, and then we're going to see how that works on the web. For that, I'm going to change to this mic. Okay. Okay. You still see my screen? Okay. Is it sufficiently readable from behind? Console? Okay. 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 Can you hear me? Okay. All right. So first of all, we're going to take a look at the contract, and we're going to deploy this and see what happens. Okay, good enough? Okay. So this simple contract has just two functions that we need to look at. Okay. The first one is the function that is called every time that somebody pushes a new commit. Okay. This is update ref. And the second one is the one that is seldom used. It's used only at the beginning of a repository usually, and you use it to say what branch is the most important one, okay, or the head branch. Usually we call it master, but it could be anything, okay. So the idea here is that if you let the application reach this super.updateRef, then the push happens, okay. If for some reason you reject or you throw an exception before that, before control reaches that statement, then the update doesn't happen, okay. So in this case, as you can see in this contract, we're defining an owner of the repository, and we're storing that in the owner variable, okay. And then we're requiring that in this particular contract, what we're saying is only the owner can modify the code, okay? So this is what this contract is about. You take a look at it, and then you see what is the governance model of this repository. It's just one guy that does all the pushes, okay? It's enough for our demo, but the idea here is that it could have a more complex rules, okay? It could check if you have enough push tokens or something, okay? Or that do you have enough tokens of the project that you're working on? Whatever, okay? That is up to you to decide what sort of contract you want to put in here, okay? You could also check whether or not you are in a set of approved users, okay? All that logic is up to you, and it's very simple to implement because it's a few lines of code to implement that logic, okay? So what we're going to do is we're going to deploy this contract, okay? And we're going to see how this works. So I'm going to create this. So I get MetaMask asking for gas. So I'm going to say yes, submit this. And I have Robston Etherscan here, and now I can see that there is a transaction pending. So we're going to have to wait a little bit for it to complete. This will refresh automatically once that happens. Any questions so far? So while we wait for this transaction to be mined? Yeah.
Do you imagine that this system is always? Do you imagine that this system is always used with the smart contract governance, or do you envision a model where it's just used for the decentralized storage itself? Because I know some projects, they have issues storing things on GitHub, for example, because it's stored in the US for export restrictions and so on. And, yeah, just centralizing everything to GitHub is a problem on its own, right? But many projects, they don't really need an incentivization layer or a governance layer. So what's the view here?
Yeah, very good question. You actually don't have to use the smart contract stuff, okay? The architecture of EtherGit has what is called a registry architecture. One of the registries is a smart contract, Ethereum smart contract registry, which is what I'm demoing today, okay? But you don't have to use the smart contract registry. You could use a local registry, for example, just store a reference in your disk. In the source code, we have an implementation of a local registry, which what it does is, instead of going to a smart contract, it tells you what it will have written to a smart contract. So you could share that with friends, okay? So you would be using Swarm, for example, for just the code, okay? But the governance of it would be maybe you and your friends exchanging emails. That's perfectly fine, okay? Okay, I think we got this mined. Okay, so I'm going to copy the contract address that came out, and I'm going to go to my console. Okay, so nothing different than Git cloning in a repository. So what is different is that instead of putting SSH :/ and such, it's going to be a custom protocol. Okay. So it's going to look like this. Okay. So I'm going git clone EtherGit :/ whatever, and that's the contract address that we just deployed. So the first step, what it does is it checks the capabilities of that repository, okay? Because of the modular contract architecture, different repositories could support different features, okay? So one of the things EtherGit does is to probe what kind of contract is it, okay? But in this case, it's a very simple one. And one of the things that Git is saying is you appear to have cloned an empty repository, okay? So it has created this folder, and this folder doesn't have anything. So it's time to start with our application, okay? So what I have done is I have prepared just a file to commit, okay? It's a simple JavaScript file, and now our repository has main.js in the folder. So what I'm going to do is well, first of all, I'm going to show you what main.js has, just for reference purposes. It has a hello world message, okay? It's a JavaScript application with a hello world message, and we're going to commit this to our contract, okay, to Swarm, okay? So what I do is git add. This is a regular Git commands. I'm not doing anything strange here. So I'm going to add main.js, and I'm going to commit this with a message. Okay. Okay. So I commit this, and now it's a commit, but on my local machine. And now I'm going to push it to the internet, to EtherGit. This is actually pushing to Swarm. So what it's doing is detecting that remote head is not set. Remote head is, as I said before, is what is the most important branch, in this case master, because this is a new repository. We didn't set what was the main branch, okay? So that is the first thing that it had to do, and it has uploaded the content, the main.js file and other objects to the repository. So we're going to see what's happening in my Ethereum address, okay? As you can see, there are two transactions in there. One of the first transaction is a one-off. Is the first time that you commit something to an EtherGit repo is going to update the main branch, but that is as a one-off operation. And then the second one is the actual push that I did. Okay. So we need to also wait for this to mine. Not yet there. So we have to wait a little bit until it gets mined. Okay, there you go. So it took about a minute to appear, but those two transactions, the two top ones, as you can see, is on the contract 0x5d5b, which is the one that we have created. So now, if I go back to my console and I remove the repository, I totally delete it, okay? So I'm going to go ahead and clone it again, okay? And then we can see that we're retrieving the file that I just committed, okay? So there you go, downloaded everything. And there's our main.js file in there, okay? Okay, we can see what it is and run it, and that's our application. So we were able to push code to Swarm and govern it with a smart contract. I could do this push because I was the owner or of the repository as expressed in this smart contract. Okay, otherwise I would have gotten an error message saying that I am not authorized to push there, okay? So now let's take a look at how it looks, how this looks on the web, okay? So I have a development server running on my computer, and this is how it looks on the web. Okay. This is a dApp, though I didn't host it on Swarm, but it's a fully static HTML application, HTML5 application that can be run totally without any sort of server. Okay, the only thing it needs is a Swarm node to connect to and a get node to connect to. So what we're going to do is we're going to open the repository that we created before. Okay, this is our repository, 0x5d. I'm going to just put a test repo or test, save. Okay, and now I can open it here, and then I can browse it as if any other tools that you guys are familiar with. Okay, I could click on the file and see the content of the file. I can look at the commits, and then I can see this is the first commit. And if I click on the commit, I get a diff of the. In this case, it's a new file, so nothing fancy there. But I get a diff of the file. I also can see what are the branches that are in my project. In this case, only the master branches there. And then we have mocked these two screens, the issues and the pull request screens, because this is still work in progress, but the idea is we also have all the issue tracking facilities in there, and the pull request as well. Okay, we could have all the different pull requests in there to approve or merge. Okay, what else can we do here? For example, let's take a look at another repository that is a little bit more complete, okay? Because our repository was only one commit, okay? It didn't have anything, but a larger repo looks like this, okay? You can click on the folders, browse code. You can go to the commits, and you click on any commit. Then you see a larger diff, with all the things that we are used to seeing in GitHub, okay? And again, in this case, for example, this project has 2 branches, and it's a little bit more interesting. What else do we have in here? So one of the things that we also have mocked for now is the create repository aspect. You could see the create repository functionality by me manually submitting a contract to the Ethereum Ropsten blockchain. But the idea would be to make it very easy for the user to deploy a new repository. So in this case, the idea is you create a repository, and it asks what type of governance model you want for your repository. You could have a basic one, which is only you are able to commit, like the one that I was showing you before. You could have a more standard one, which is I am able to push to the repository, but also my friends or colleagues or a list of particular people. And then custom would be write your own contract and do whatever you think is good. Okay, you define all those rules in there. And also other things that we uploaded here just for a demo is our own repository. We host it there as well. But also the Go Ethereum repository is here. So here you can see, well, it's a Git repo, so we pushed it to Swarm, so it's just hosting itself. I think that's kind of cool. And okay, so this is the extent of the demo. So let me go back to the presentation. Okay. So roadmap, things that we would like to do next. We would like to complete the HTML5 dApp that you saw. Okay, so it's fully functional. It has all the things like issue and PR tracking, that you can edit code online, that you don't need to use the command line git to edit a file for a small change. That you can also merge PRs on the web application. We need to improve the performance of the different aspects of pushing code and downloading code. We want to also provide some sample contracts that are a little bit more advanced than just I can commit and you can't. Okay, And then we want to also add a bounty issue management built into the whole platform so that a particular team can incentivize others to contribute, okay, with whatever system they come up with, okay. And also a modular repository contract editor where you can just find some modules that are interesting for your contract, and then you put them in your contract, okay. And then once we want this to scale, not everything can be done at an HTML5 browser application. We will probably need some sort of server-side or node type of component that takes care of indexing and searching and things like that, that a browser is not going to be able to do. But in essence, I would say that the roadmap is to get rid of GitHub altogether. Okay, that is a very ambitious goal, but the idea would be to go for it, really. Okay, so with this, thank you very much for your time, and any questions, very much appreciated.